On entend tous les jours dans l'actualité parler d'intelligence artificielle. On nous explique comment elle nous induit en erreur avec des images deepfake.
I am not Morgan Freeman, and what you see is not real.
Comment elle va nous remplacer au travail. Ou comment elle va liquider l'espèce humaine. Pour l'artiste et chercheur britannique James Bridle, si les avancées et les risques de l'informatique sont le plus souvent exagérés, cet emballement pourrait être une porte d'entrée pour qu'enfin on s'intéresse aux innombrables hautes formes d'intelligence non humaine. Dans son dernier livre, Toutes les intelligences du monde, James Bridle nous invite à sortir du cadre étroit établi à la fois par les entreprises technologiques et par le dogme de l'exceptionnalisme humain pour penser et pratiquer l'intelligence autrement. Les êtres humains ont-ils vraiment le monopole de l'intelligence? Y a-t-il besoin d'avoir un cerveau pour être intelligent? Qu'est-ce que l'intelligence? Ce qui intéresse James Bridle, c'est moins les prouesses de l'IA, qui sont selon lui surfaites, que la fascination qu'elle exerce sur nous et sur notre imaginaire. Dans les films de science-fiction comme dans les médias, l'intelligence artificielle est souvent présentée comme une menace pour l'humanité.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me. And I'm afraid that's something I cannot allow to happen.
Mais encore faut-il savoir ce que l'on entend par intelligence. C'est la question du livre. Il y a plusieurs manières de la définir. On l'associe souvent à la capacité à apprendre, à comprendre, à raisonner, à résoudre des problèmes, ou encore à la conscience de soi, mais aussi à la faculté de percevoir des émotions. Et on a du mal à trancher. First, what are we talking about? How do we define intelligence?
Intelligence or artificial intelligence?
Intelligence.
Intelligence. The thing is, we're quite bad at defining intelligence. There's not really one definition that everyone is happy with. It's one of these words that we use very, very loosely, depending on the particular kind of subject that we're interested in. Mostly what we mean, most broadly in everyday conversation, is really we mean what humans do. Because most studies, work, research on intelligence in history takes the human as baseline. It says, like, intelligence is what humans do and we'll judge everyone else by it. And so it becomes a kind of red line between us and other species or between the abilities of computers. And also a kind of imaginary finishing line as well. It's like, oh, if we could just build computers that did this, this, and this, they'd be intelligent in this particularly weird way.
The computer, an ingenious collection of electronic hardware, was created by man. It is also man who creates the programs that make the computer the useful tool that it is.
Si in fine on a tendance à considérer l'intelligence comme étant ce que font les humains, alors il est logique qu'un des courants les plus importants dans l'histoire de l'intelligence artificielle, le connexionnisme, recourt à la métaphore du cerveau. Et de fait, on parle de réseaux de neurones artificiels pour désigner les machines qui apprennent, comme par exemple ChatGPT.
And it's actually very important again to understand like the way in which the current generation of this thing that we call AI has come about. Because it's really not a very new idea. Since the 1950s and 60s, there's been an idea called connectionism. Okay. There was essentially that if you could kind of build a computer with enough connections between them, maybe as many as there are neurons on the brain, you would sort of magically manifest intelligence as a result of all these things being connected together. It turns out that's kind of partly true, in the sense that if you build what we call a neural network, which is a computer system that has all these kind of little connections inside it, essentially, then it's capable of doing this very powerful reasoning. And it's very good at particular things like sorting, calculating, classifying. That's why it's very good at playing with images, because it can recognize all of these tiny details in with them and make associations between them. It's very good at that kind of intelligence, but only really at that kind of intelligence. And that's why it's sort of quite narrow. And the really kind of killer detail for me is the fact that like there have been some sort of technological breakthroughs in the last 20 or so years around neural networks. They've built certain chips that are better at doing this kind of modeling and so on and so forth. But really what's happened isn't technological at all, it's political and social, which is that for the last 20 years, a few companies, Facebook, Google, Amazon, the companies that are building these big AI systems have been making huge amounts of money off online advertising or sales, and they've been collecting vast amounts of data associated with that. And they've got the money to invest in very powerful computers to process that data. And it's that they built AIs out of. So once again, we have this very particular kind of intelligence that's built on large-scale data acquisition that's only available to the richest companies on Earth. And that's not the best way to produce what most of us would consider to be intelligence.
Autrement dit, les performances de l'IA se sont certes accrues depuis 20 ans, notamment grâce à l'explosion du nombre de données disponibles, mais au fond, tout cela ne sort pas du cadre très étroit de ce qu'il appelle l'IA d'entreprise.
When I think of AI today, I think of self-driving cars, facial recognition. It's what you call corporate AI. Can you tell me what you mean by that? What characterizes our dominant form of AI?
So there's a few things that characterize this kind of AI we have in the present moment. The first one is it's the kind of AI that's made by corporations. So they have a kind of particular imagining of what the world is like, what it might be like, what it should be like, what they'd like it to be like. And you can see it in the kind of things they make. You can see it in their obsession for a long time with winning at games. So before we got into a lot of the current kind of image generation and stuff, a lot of the AI stories are around things like chess or Go, these board games that AIs were trained constantly to play. And this goes way back to, a long way, but famously back to the kind of game between IBM and Kasparov in 1990, I think it was, Deep Blue.
Le champion du monde d'échecs vient d'être battu en combat très singulier par une machine. Il était certain pourtant d'en venir à bout. Cependant, l'intelligence a dû laisser place à la formidable puissance de calcul et implantée dans les entrailles d'un ordinateur d'1,5 tonne.
IBM built this huge machine just to beat this guy at chess. They were completely obsessed with it. And he was pretty upset, and understandably. But a lot of people actually came away from that thinking, like, maybe this isn't, like, the best way to prove that computers are intelligent, just to beat humans. But a lot of the big companies sort of didn't really get that, and they kept building these machines that try to prove their intelligence by winning. And that's a kind of market-based kind of intelligence.
L'IA dominante est donc malheureusement celle que produisent les géants d'Internet. C'est celle de la reconnaissance faciale, de l'arbitrage financier, des systèmes d'armes autonomes ou encore de la prospection pétrolière. Et comme il l'écrit dans son livre, on peut s'interroger sur l'intelligence de systèmes qui aident les êtres humains à perforer, assécher et saccager les rares espaces sauvages qui subsistent sur Terre. Pour autant, il arrive que certaines expériences produisent des résultats inattendus qui sortent des cadres initialement prévus. Par exemple, en 2017, Facebook a créé 2 réseaux neuronaux pour voir s'ils étaient capables d'apprendre à négocier en ligne. Chacun avait un stock de balles, de chapeaux et de livres fictifs à troquer. Et on a découvert plusieurs choses. D'abord, que ces chatbots négociaient beaucoup plus durement que des êtres humains. Ensuite, qu'ils avaient appris à jouer la carte de la tromperie, à faire semblant de s'intéresser à un objet. Mais surtout, il s'est passé autre chose.
They tried to basically see if 2 automated systems, 2 chatbots, basically, could bargain with one another. And what they didn't do was particularly specify the language or the way in which they had to talk to each other. And what happened, as happens quite often when you have these automated systems just kind of running to themselves, they essentially develop their own language.
Bob, I can everything else. Alice, balls have 0 to me. Bob, you are everything else. Alice, balls have a ball to me. Bob, I can everything else. Alice, balls have a ball to me.
And this was a language that rapidly became completely inscrutable to humans. But it also was one that absolutely seemed to function. And what they stopped the experiment basically when it reached the point at which humans could no longer meaningfully understand what was being done. And so for me, one of the kind of interesting things about AI is it provides a very narrow, clear definition, a little box that we can put around the things that say, look, we don't really know what's going on in here.
Quand Facebook a arrêté l'expérience, ça a donné lieu à quelques titres sensationnalistes dans la presse. Mais pour James Bridle, la crainte de perdre le contrôle sur des chatbots intelligents qui finiraient par prendre le pouvoir et dominer le monde est surtout révélatrice de notre conception anthropocentrée du but de l'intelligence.
Dis donc, Cortex, qu'est-ce que tu veux faire cette nuit?
La même chose que chaque nuit, Minus. Tenter de conquérir le monde.
Pour lui, au contraire, c'est justement au moment où l'IA de Facebook a commencé à s'autonomiser en développant son propre langage qu'elle devenait intéressante. Et plutôt que de s'alarmer, il se réjouit à l'idée que le comportement d'une IA puisse échapper à notre compréhension et à notre maîtrise.
We have to figure out how we live alongside these systems that no one can kind of fully scrutinize. And again, what's super interesting about AI is it forces us to to think about what some of those relationships look like, because we kind of have to acknowledge AI is real because we made it. However unimpressive it is in many ways, like it fails in all kinds of ways, or whatever, you know, how it doesn't live up to this kind of grand idea of human intelligence, it's doing really interesting things. And we know it's doing interesting things, and we're studying it because we're so obsessed with it for a whole bunch of strange reasons. And so it provides a test case for how we relate to something non-human. Yeah. And when you start to really think about what that means, then you have to start like thinking about all the other things that we dismiss as non-human as well. And so if AI is interesting, it's that because it says to us that like human intelligence isn't actually that unique. Like we're not the only ones that can draw pictures or do all these kind of things, even if the pictures are awful, right? And so that must make us aware that human intelligence is not so special and unique as on some level, all of us really believe it to be. Because we kind of need to believe that. But we also radically need to believe otherwise. Because it's precisely that belief in human uniqueness and therefore superiority that has led us to treat the rest of the planet as we have been doing for so long.
Pour James Bridle, c'est l'effondrement écologique en cours qui exige de nous que nous remettions profondément en cause notre complexe de supériorité d'être humain et que l'on apprenne à percevoir les signes d'agentivité et d'intelligence des autres êtres qui peuplent ce qu'il appelle le monde plus qu'humain. Une formule qu'il emprunte au philosophe et écologiste américain David Abraham. Dans cette perspective, James Bridle mobilise un terme allemand qui n'est pas évident à traduire, Umwelt.
So the Umwelt, this term was coined by a kind of biologist called Jacob von Uexküll in the 19th century, and it describes the perspective on the world, the way of being in the world of a particular organism, not a particular species, but an individual organism. It's the way they perceive the world. One of the classical explanations for the Umwelt, of what it might mean to understand the completeness of Umwelt, is of a tick, one of those little biting insects. And according to people who've written about Uexküll's work, the tick's Umwelt consists of the temperature of the air that it senses around it, because it can sense the passage of warm-blooded animals. And it's the smell of butyric acid, it can sense that. That tells it where to find blood running through a warm-blooded animal. And the senses it feels from its hands. It's blind, but it can move around and hold on to hairs. So it has 3 senses. And those 3 senses comprise the entirety of the tick's world. That's its Umwelt. Now, our Umwelt is, we imagine, somewhat richer than that. But what's crucial about the Umwelt is it's also unique to every individual. And so we're all constantly creating the world all the time through our own perspective, and then we're acting on it. And our intelligence manifests as a result of that Umwelt, as being part of that world. And so, of course, if a creature has a different type of Umwelt, have a different set of senses, whether that's a tick or a duck or a dolphin, they perceive the world in different ways, and so they act, and their intelligence manifests in a different world, in a way that's entirely embodied in a result of that awareness.
L'Umwelt d'un organisme, c'est donc son modèle interne du monde, avec ses connaissances et ses perceptions. Le concept est utilisé depuis longtemps aussi bien par des spécialistes de la robotique que par les biologistes. Or, tant qu'on ne considère que l'Umwelt humain, on ne peut pas reconnaître les autres formes d'intelligence. Il donne un bon exemple dans son livre, celui des gibbons. Des primates qui semblaient échouer au test d'intelligence où ils devaient tirer sur une ficelle pour obtenir une friandise. Le problème, c'est que le dispositif ne prenait pas en compte leur Umwelt, leur mode de vie arboricole et le fait qu'ils se déplacent de branche en branche et ne font pas attention à ce qui se passe au sol. Il a suffi que l'on accroche la ficelle au plafond pour que les gibbons passent le test et que l'on comprenne qu'ils étaient bel et bien intelligents. Alors c'est vrai que ça fait quelques années que l'on sait que les singes peuvent être malins, mais à la limite ce n'est pas étonnant parce que ce sont des primates comme nous. Or, de plus en plus, on se rend compte que des formes très impressionnantes d'intelligence existent chez des espèces qui ne nous ressemblent pas du tout, comme les poulpes.
Yeah, I mean, octopus is having a bit of a sort of star moment at the moment. But there's really good reason for that, which is that they are quite extraordinary creatures that are so radically different to us. It's weird, because this is some kind of strange, squishy being that lives entirely under the ocean, that only lives for 2 years at a time. You know, that mates, reproduces and dies in very quick succession, and yet is capable of quite amazing feats. They're particularly famous for escaping from aquariums. They can recognize individual humans. We can't recognize individual octopuses, but octopuses can recognize individual humans, and they have favorites. They respond nicely to some researchers in laboratories, and they squirt other ones with water. So they have this entire repertoire of obviously intelligent behaviors. But what's strange about that is, as I said, how different they are to us. They're different in the way that they're embodied, the physical fact of living underwater, but also the way their brains are structured.
Une des caractéristiques du système nerveux des pieuvres, c'est qu'il est un petit peu délocalisé. Il y a pas un cerveau par bras, mais il y a des gros ganglions au niveau des bras qui vont servir à l'animal à filtrer toutes les informations, les millions d'informations qui lui parviennent de ses ventouses. Dans les ventouses, la ventouse, c'est un organe extrêmement sensible. Donc tout ça sont des petits cerveaux qui servent de cerveaux annexes, qui permettent de filtrer des informations. On pense que ne parvient au cerveau central que les informations sans doute les plus importantes. Mais ça, c'est sur les mécanismes. C'est quelque chose de très très innovant par rapport à ce qu'on connaît chez les vertébrés.
James Bridle s'amuse à pousser loin le brouillage de la notion d'intelligence. Pour lui, le terme ne s'applique pas seulement aux animaux, il peut aussi être utilisé pour décrire le comportement des végétaux.
In the last kind of couple of decades or so, scientists have really started to understand these networks of nutrition and information sharing that underlie the forest. And it's really extraordinary as we start to understand the amount of kind of signaling, the amount of information that's passing around between trees.
Le réseau mycorhizien peut interconnecter des forêts entières. C'est pourquoi les chercheurs parlent de l'Internet de la forêt.
You know, a tree that is attacked on one side of the forest, by insects, for example, when trees are attacked in that way, they send out a particular chemical. They send signals through mycelial, these kind of mushroom-based networks underground that are connected to all the other trees, and the trees respond. And they don't just respond into these kind of one-to-one, one-way signals. They respond in ways that allow them to cooperate.
L'exemple des arbres illustre bien l'idée que l'intelligence est multiple et essentiellement relationnelle. Et dans son livre, Bridle développe toutes sortes d'exemples similaires, que ce soit avec les abeilles, les fourmis, les champignons ou les mimosas. Mais je crois que celui qui m'a le plus fasciné, c'est celui des myxomycètes. Alors les myxomycètes, ce sont des organismes unicellulaires, des espèces de moisissures. Et ce qui est fou, c'est qu'ils arrivent à résoudre des problèmes hyper complexes beaucoup plus rapidement que les êtres humains et même que les ordinateurs.
They're capable of doing really extraordinary things. I mean, they are already obviously extraordinary beings. They live in these little kind of fluorescent patches on forest floors. And they have a life cycle that we don't really understand. We don't even know where to put them. They're not fungi, they're not kind of algae, but they're somewhere in between that kind of mess of little creatures that we have trouble relating to. And at some points in their life cycle, they're just kind of free-floating cytoplasms. And at other times, they actually grow together, grow and fruit like fungi do, with many of them dying. And like there's a kind of collective action for the collective to survive. And they're capable of apparently doing things that we don't really understand, like incredibly complicated calculations. One of the first things researchers did was some brilliant researchers at the University of Tokyo. They put these slime molds, these little microorganisms, on a Petri dish in which there were oat flakes that corresponded to the population centers of the kind of greater Tokyo region. And what the slime mold does is it spreads out trying to find what turned out to be the most efficient route between those places. And after 24 hours, the researchers realized that the slime mold had basically recreated the Tokyo rail network. That had done this thing that took engineers like 100 years to do. It figured out the most efficient route between these places. It's much more complicated than that, what it did, but it's still utterly amazing. But they subsequently discovered even stranger things. There's a very difficult problem in computer science called the traveling salesman problem. And the traveling salesman problem says, what happens if you want to get, from between, say, 5 or 6 cities to deliver something? You have to go to each of those cities, visit them only once. What's the shortest way of doing it? A, B, C, D. That's a really, really hard problem because there's no shortcut mathematically. You just have to measure every different possible version until you can figure out which is the shortest. That makes it what's called an exponentially hard problem because if you add one city, you have to measure them all again, right? Which means that the kind of graph of the time required to solve it goes like this, right? It's the kind of problem that we and computers absolutely hate, right? Slime molds, through a quite ingenious experimental process, have been shown that they don't need that time to figure it out. They can solve this problem in linear time, right? So the graph just goes like that as you add cities. Now, we have no idea how they do it, but they are better at solving this particular mathematical problem. Better, not only than humans, but than the best, most powerful supercomputers we've ever devised. And they're probably doing all kinds of other cool stuff that we have no idea or access to at all. Like, this is a nothing to them, right? But it's just something that we've kind of figured out, like, this question that we can ask them, and they have a really, like, meaningful, simple, duh, kind of response to it. And so researchers go out and finding all of these kind of strange abilities in the world that for me mostly just show how, again, narrow much of our thinking is in relation to all the possible ways of thinking that already exist out in the world.
Ces mixomycètes sont des espèces d'ordinateurs, de supercalculateurs vivants. C'est pour ça qu'ils passionnent les spécialistes d'informatique dites non conventionnelles qui explorent des méthodes de calcul non électroniques. Ces chercheurs ont par exemple créé des ordinateurs avec des champignons et même avec des crabes. Et là encore, on arrive à élargir la notion d'intelligence au-delà de l'Umwelt humain, puisque celle des champignons ou des mixomycètes ne passe pas par une intentionnalité consciente, mais par une action.
That example is also interesting because there's not even a brain here now anymore. There can be intelligence without a brain.
So one way of understanding this new mode of intelligence is simply not as something that just happens in a brain. We've liked to think, again, because we have large ones, that the brain is this kind of thinking organ. And it's true, in humans, the brain does a lot of memory storage and cognition, so on and so forth. But even like the octopus, not all of our neurons are in our head. We have neurons in our heart. We have actual neural nodes otherwhere in our body, and it's increasingly evident that the whole body is a thinking organ in that way. And we start to understand that there's this connection between thinking and acting, that we think the way we do because of the kind of bodies that we have. As I said earlier, talking about how different species enact intelligence differently, it's because they have these different body plans and these different relationships with the world. So intelligence is really, to my mind, because we're all just making up our own definitions here, is what happens when that kind of thinking, that processing, that whatever you've got inside the brain and the body goes out into the world and starts to relate.
James Bridle nous propose une révolution copernicienne. Plutôt que de se demander si telle machine ou telle espèce animale ou végétale est plus ou moins intelligente que les êtres humains, il propose de repenser de fond en comble la notion même d'intelligence. Car ce n'est pas seulement une capacité mentale humaine que les entreprises peuvent tenter de reproduire par des algorithmes. L'intelligence est aussi quelque chose que l'on fait, elle est active et relationnelle. Pour lui, reconnaître toutes ces manifestations est une étape cruciale sur la voie de notre réenchevêtrement avec tous les êtres, aussi bien biologiques qu'électroniques, du monde plus qu'humain. Pour aller plus loin, mes sources sont en description et pour garder les idées larges, il y a d'autres épisodes. À bientôt!